what is this? What is that? Well, what does that question mean? Well, many different answers. Well, what does it show us? Well, first it shows us student at netlab 24 $, and I think you've been typing commands, you may have seen it change sometimes. What information does it show us? Student is the username. I'm logged in as student. At netlab 24 is the host name, the name of my computer. I'm actually logged into the computer at the back. Yours would be netlab 1, 2, or whatever the computer number is. So that's the name of the computer. Colon, the tilde represents your current directory. Tilde, remember, is your home directory. /home/student. This is just a shortcut. And dollar means from now on, everything beyond that you type. This is called the prompt. Okay? And the prompt, in this case, can provide some useful information: who I am, what computer I'm on, what directory I'm in. Why do we care who I am? I could log in as someone else. I can actually, I don't know if you can, but I can switch to instructor. I need the password. You could probably guess it. Now I'm logged in as instructor on this computer, and now it shows me I'm instructor. So that's useful information in that it reminds us who we're logged in as. This reminds us what computer we're on. You've already used Secure Shell to log into other computers at the start to run this mux to view my terminal. Sometimes you forget, you run a command, you think you're doing it on your computer, but you actually log into another computer. So this is a little bit of a reminder. Which computer are you logged into? And this is a reminder of where you currently are, your path. This is called the prompt. And what we type beyond the $sign is what is executed. Let's log out as instructor. We can change the prompt very quickly. First, the things that we're going to do, most of the commands that we're going to demonstrate are on one of these two web pages, and these are linked to from the Moodle workshop. You go to the workshop, the resources, there's aliases, prompts and scripting, and wget, pdftk, and so on. Those two websites, I list most of the commands we're about to do this afternoon. So it may be useful now to open the website, and you may be able to even follow along there. We will not do all of them. So this one on aliases, prompts and scripting has some information about manual pages, man pages. We will not do that now. Have a read through in your own time. Then it has something on, there's some more new information there. Aliases, we may not do that at all. I'll scroll down a lot. Shell prompt, okay? So the things I'm about to type, some of them are, most of them are on this website. Okay? So you have your own reference for later. Echo, we saw towards the end this morning that Echo displays something on the screen. What's something? The parameter. Echo hello prints hello on the screen. But in the shell, right, what is the shell? When I say the shell, the language that this terminal interprets, we refer to as the shell. Okay? So the commands that we have here and the way it outputs things, the shell is the piece of software that manages all of this. There are different shell programs. The one we're using is called Bash, B-A-S-H, born again shell, but there are others. Now, the shell is like a language. It's almost like a programming language. We'll see some constructs later, but we can have variables. Think of them environment variables. In Windows, you may have set the path. The path is an environment variable. We can do the same thing in Linux and other Unix operating systems. So, echo hello prints the string hello, we can create a variable, whatever I like to call it, like this. And we can echo the contents of that variable. This is not about the prompt, this is just something about the shell. I can create a variable, ABC, by assigning it to some value, in this case a string, Steve, and I can display, or I can refer to the value of that using $ followed by the variable name. We'll use them as we go through some examples. A variable, sometimes we enclose the variable with sort of the full ways to enclose it with curly braces. The same thing, $ followed by the variable name, or $ enclosed in curly braces, the variable name. Just two different syntax. So, there are some variables which are defined in the shell already. I just defined ABC, and I can define others, but there are some already defined environment variables. One of them is the format of the prompt, and it's called PS1. So the variable name that defines the format of the prompt is PS1. Some strange string. Echo $PS1, some strange string. Forget about this Debian, CH root and so on. Again, we don't have time to cover everything. Look at the last few characters. It tells us the format at which the prompt should be printed on my screen. And I've known, I studied before, that /u means display the username. @/h means display the host name, the computer name. :/w display the working directory. And then $$ means show an actual $sign, because it's a special character. So these characters define how the prompt is displayed. We can change them. PS1 equal to, I'll put it in quotes, you can change it to whatever you like. You can define it as just a string, or you can use these special characters to get particular values. So PS1 is just a variable which defines the structure of the prompt. Okay. If you look through the man pages, you'll see the definitions of these special characters and many others. And that's not what I'm doing today. You can find them in your own time. That's just a quick explanation of the prompt, and let's change to maybe something different. Do we need $? I think we should do dash. Okay, so change the prompt to whatever you like. In this case, I've changed it to just display the username, followed by a $, space, and then what I type in. That's the prompt. In the website, there are a few more examples of the prompt which we will not go through. You can change the color. Okay? So the terminal in the basic form is black and white, or just two colors. But most computer systems support multicolored terminals, so we see the different colors of the directories and files. We can also change the color of the prompt. I'll copy and paste one from the website, so they don't have to waste my time typing it. I think I've made a mistake on the website too. What? Maybe not. Okay. We can change the color. Okay. Amazing. with this long set of commands. Some of those strange characters define the colour. This /e in brackets 1:34m defines the colour to be blue of the prompt. Again, I copied that from the web page. Remember to copy and paste. Go to the web page, select. You don't need to right click, just select. Go to your terminal and middle click. Okay. Now we have a beautiful prompt. Some things that this afternoon we'll go through quickly just to make you aware of those things. Like you're aware that this is the prompt and you change it by setting PS1. Exactly how to do it, what possible values you can set, I'll let you explore in your own time. We will not go into any more detail. The website, that web page, has some more details and also will point you to where to find more information. That's the prompt. Can I go back to normal? What was it at the start? I think it might have been this. If you want to go back to the original one, you can copy it from the website, or much easier, exit. Type exit, the terminal will close. When you start the terminal again, it will go back to the original. Okay? So the changes only apply, it's not permanent, only applies during this terminal. To make it permanent, we'll see how later. Okay? It's not too hard. We'll see it with something else. So for you, I will not do it, but you can exit and start a new terminal. Another variable. When I run ls, ls is a program. It's an application. Where is it? Which ls tells me ls, the executable file. In Windows, it would be an exe file, ls.exe. Here it's just ls, is in the /bin directory. Why does my shell know, when I type ls, why does it know to execute ls from the bin directory? There may be a copy of ls in other directories. It knows from what we call the path. The path defines what directory should we search to find an executable. And it's just another variable. If you echo $path, path is the variable, dollar refers to the value, echo will print out that value, shows a set of directories separated by colons to say that when you try and run a program, the shell will look in these directories in order. It will first look in home student bin and then, or I've got home student bin again, that's a mistake, and then these other directories. I set something up yesterday that made home student bin repeat. So this is the path. You can change it. I don't suggest you do. Now, just make sure that you do have home student bin in your path and at the start. Some of you may not if I didn't set the computers up correctly. This is saying when I run a program, the shell will look in this directory first to see if that program exists. If it doesn't exist there, it will move to the second directory. If not there, it'll keep going. If it doesn't exist in any of these directories, it will return an error, command not found. Normally, home student bin is not in your path. I have added it because we have some software that we're going to create ourselves that we'll put in this bin directory that we want to use during this afternoon. Anyone not have /home student bin at the start of their path? Not have it? Who doesn't have it twice? Having it twice, it shouldn't be there twice, that's my mistake. But it won't hurt. If you want to add something to the path, maybe echo will take let's try. I had a variable, we'll do it with something else. I had ABC. Echo, you can combine variables and strings. So I have my variable ABC, which is defined to be Steve. If I try to echo $ABC hello, it doesn't return anything. It prints out empty space. That didn't work. But if I enclose ABC in the curly braces, echo ABC followed by the string hello, it prints Steve hello. So it's very easy to combine values together, concatenate the strings. We can do the same with a path. Sorry. Yeah. Echo $, and that's why we should put things in curly braces. If you had a new directory called new bin, I'm just making it up, we could add it to the path. That is, we can concatenate the existing path and add on this other string at the end, which would include a new directory. And to set that, we would say path equals existing path plus the old path, plus the new directory. Set the path to be equal to the existing value of path combined with this new directory, which would effectively add that to the path. Just a reminder, of course you can look on here, but you should be able to see what I'm typing via the terminal if you're using Mux. But if you shut it down or for some reason not working, anyone not have the terminal open? If you okay, you can see it. All right, I think most people are okay. Just make sure. So instead of having to see up there, Mux is working okay. All right, good. Just to make sure. Are you going to set your path? Press enter now, and that directory will be added to your path. I don't want it there, so I'm not going to press enter. But you can do it, it won't hurt. Okay, we'll do it. Now my path is everything as it was before, plus /home /student /new bin. Okay. Which means when I run a program, what the shell does, it searches through all of these directories to look for that program. Ask questions as we go, otherwise we'll just quickly move on to the next thing. Is that a question at the back or is that a yawn? I think it's okay. Now what we're going to do is put the commands that we've been running. Remember, we run a command, press enter, run a command, press enter, put them inside a file and run that file. A text file. So I'll just clear, we'll start again. We'll use my text editor, Nano. For you, you may want to have multiple terminals open. That is, 3 terminals. 2 of them for your computer and 1 to see what I'm doing. Sometimes it's useful to have two terminals, maybe open an editor in one and execute in the second. But I will not, just for the limited screen space. Let's create an example. If I can spell. No. Example 1. Remember, file extensions mean nothing in Linux. It doesn't matter what file extension I add. It doesn't matter if I don't include a file extension. It doesn't have to be .txt. In this case, I'll just call it example 1. Nano is our text editor, like Notepad. And now we can put commands in there. What? cd home ls. ls minus l. That is, I want these three commands to be executed when I run this example 1 file. Rather than having to type each command myself, put them in a file and run that file that will run those commands. So I've just put 3 commands as an example. Should take me home. cd tilde means go to my home directory. Should ls, and then ls in the long format. Exit, control X. Save modified buffer, yes. Y for yes. File name, press enter. You want to check if it's there, cat just shows you the contents. Now, how do we run it? I want to run the commands inside example.1. Well, the name of our shell is called bash. And the way to run, one way to run this example.1 is to type bash example.1. Remember to use tab. Bash e tab, autocomplete. Bash is the shell which will execute, in this case, should execute the commands inside this file. Does it? Yes. You see the output of those 3 commands. The first command had no output. It just moved me into a directory. The second command, it's not so nice on my screen, but the second command was ls. It shows these files. And the third command, ls minus l, which shows those files in long format. There's what's called a shell script. A script which allows you to automate tasks. Any problems with shell scripting? Very easy. Just put your commands inside a text file and run that text file. Did it not work for someone? Anyone? Or maybe a better question, who got it to work? Put your hands up. Yes, sure. Okay. If you didn't get it to work, did it run? Yep. Okay. Very easy. Now, let's cover a few more details about those shell scripts and see a few different things we can do inside them. I'm going to open mine in my text editor again, Nano example 1. It's good practice, so we can just include the commands, but it's good practice to in fact include a special instruction at the top of the file to say which shell program to use to execute this. And it's a very special syntax. The first line should be hash, exclamation mark, and then the exact path to the shell script, the interpreter. And we're going to use bash for all our examples. If you don't know what this means, don't worry, just use it in the top of all your shell scripts. It doesn't have to be bash. It can be others. In fact, others may be better in some cases, but we will use bash for simplicity in our case. Hash is normally a comment in shell scripts. Anything after a hash is usually a comment. In this special case of the first line, when it's combined with the exclamation mark, it's not a comment. It's a special instruction saying, if you execute this file, use bash to execute it. Don't use some other interpreter. Hash exclamation mark is called bang. So this combination is called shebang. Hash bang, shebang. So include that at the start of your scripts. When you execute it, Control X, save yes, enter, again. Run it, you get exactly the same. Nothing has changed with regards to the output. Let's do something different. Let's move the example1 file into your bin directory. Remember, move will take this file and put it into another directory. So it moves it, doesn't copy. We're doing this because our path includes the bin directory. What we want to do is be able to run this command without having to type bash example1. I want to just type example1. So we'll set that up. Move it into bin. And let's cd into the bin directory. There's already some programs in there from some I've installed, FFmpeg. And example1 is there. Again, something that you may not understand but you need to accept for today with limited time. We need to make this program executable. Currently, example1, we are allowed to read it, we're allowed to write it, we're not allowed to execute it. We want to be able to execute it. How do we make it executable? This magic command. Change the mode such that the user can execute example1. And now we see an X here. All right, again, permissions, changing the mode is something that we may cover in the lab in semester 2 for those that haven't taken it, or in something like ITS 335, IT security if you're an IT student. But we will not cover today. You see the colours change to green. That's a nice sign. Example1 is now an executable file. And because it's in the bin directory, and the bin directory is in my path, I can just type example1 and it executes. Yep. Sorry? Okay. So you should be able to just type, you don't have to type bash example1, just type example1 if it works. Change the mode. Now, where's the command? Sorry. All right, I need to scroll, sorry. Something that I did, which we didn't explain much, you must do this. chmod u plus x example1. Make that program, make that file executable. Then you should better run example1. Anyone else have problems? Okay. So we now have our own program, example1, which actually just calls other programs, ls and cd. Let's do some more things with a script. Let's copy example1 to example2. We'll go through a few examples. Or a quick one. Now let's edit example 2, nano example 2. Open up example 2 in your text editor. And let's change it to be something more interesting. Sorry, what did I do then? In Nano, to delete a line, I can do Control K, cut. Control K. You can delete normally. Let's create a variable. Don't copy me. Set a variable to some value, the first line here, and then echo some string, my name is, followed by the value of that variable. Save and execute. I'll leave it up there for a moment. You can save that, exit Nano, and execute example 2. Save. A quick way to save is just exit. Control X, save, yes, enter. Execute. Example 2. All right, so this is just our use of variables. Same on the command line, we can use them in scripts. Next, the shell. All we've done so far is run a command and we get the output. Well, it has more complex syntax and it allows different programming constructs. It allows what we'll use for loops, if statements, while loops, and many other constructs. So we'll just introduce for loops and then if statements, and we'll do it inside the shell script. I'll just keep copying in my example to a new one, just so I could have a record of the old files. Copy example 2 to example 3, and then edit example 3. I don't want those lines. Let's make something more interesting. For loops, the syntax, there's different types. There's different types of syntax for loops. Let's go through a few common ones. For 2 left braces. For example, I equal to 1. This is similar to C syntax. I less than 3. I plus plus, where I is our variable. Semicolon to close. Do. And I'll use a tab just to indent. You don't have to. Echo $I. Done. A simple for loop. So we're just trying to introduce you to the syntax. What you put inside here, well, it can be as complex or as simple as you like. Here we're just echoing the value of I. You could put in your own commands, ls, copy files, whatever you want to do inside that for loop. So the syntax, 2 left parentheses, I equal to 1, semicolon, I less than equal to 3, semicolon, I plus plus to increment I. Yep. Why would you not have 2? How many do you want? Just 1. Why? Why not a square bracket, a square brace? Why not a hash? It's just the syntax. Okay. Now, why did they choose? So the designer of this language, why did they choose this syntax? I don't know. I have to ask the designer. But I suspect it's something to do. Brackets are used a lot in shell for other purposes. So I suspect using a single one may have been conflicting with other purposes of the bracket. Okay. In fact, I think this is a new addition, relatively new compared to the early versions, this syntax. While we're here, Well, no, let's execute. Save, Control X, save, and run your example just to be sure you know what's happening. Example 3, magic, 1, 2, 3. Once it's run, then edit again and we'll add a few more examples of the for loop syntax. Anyone not get 1, 2, 3? Okay, at the back? All right. Then open it again and we'll add some different syntax. Another syntax for some variable in some list of strings, for example. Semicolon to close, do. Whatever you want to do, echo the name, done. So just a different syntax for the loop conditions. This is the typical C where you increment a counter, for example. Here, for name in this list of string values. So in the first instance, name will be Steve, and then it will be Tanarak, and then Pakini. Okay. And I think we've got one more. We can use similar syntax, and this will introduce a new shell operator. Instead of defining the list here, Steve, Tanarak, Pakini, sometimes it's useful to define those list of values in a file, say a text file, one per line. And then get the for loop to read that text file. And one way to do that, I'll write it. I forgot to create the data. Actually, let's go back and create the data. I'll come back to that one. Let's save our file. If you've got that line there, that's okay, but I want to create the data first. Save the file, exit. We'll come back to it in a moment. And now let's create some fake data. Data1.txt, I will call it, .txt. Nano data1.txt, and let's put some data in it, and you can either type it yourself or if you can go to the website. I have an example. I'll show you. Again, the website is Linux command line, aliases, prompts and scripting. Scroll down, find our examples of shell scripting. Example, where do we get to? Data1.txt. I'm going to copy and paste these 3 lines. So if on the website, if you don't want to type it, you're lazy like me, you go to the website, copy, which is just select. I'll go back to that and go to Nano and middle click, paste. So on the website under for loops, there's an example that says cat data1.txt. I'll zoom in. Under for loops, this is the data I want in the file. It means nothing. Okay, it's just something that we use as an example. If you can't copy it, you have to type something yourself. Just those 3 lines, starting with 1, 2, 3, ending with GHI. So your file data1 looks like that. Save it. Yes, just to check, cat data1. Okay, data1 contains those 3 lines of text. What are they? Just some random or some strings separated by commas. We'll use those commas as field separators in a moment. 3 lines with 3 fields each. Now go back to our example 3 and finish our for loop. open example 3 in Nano, press enter, and we'll add one more for loop, the third for loop. And again, if you're lazy, you can go to the website and copy the for loop. Just make sure everyone has that so far. Okay. All right, and then we'll go back to the for loop. Again, if I go too fast, then you need to let me know, or just ask one of your neighbours for a bit of quick help. Back in my example 3, let's add the third for loop. For line in cat data1.txt, semicolon, do, and we'll do what we want to do. But let's first look at this syntax. So line is just the variable. We can call it what we like. It doesn't have to be line, it can be ABC, anything. It's a variable. And it's going to take the values of the output of this command. Note these characters called the backtick operator sometimes, backtick. So the apostrophe leaning backwards. It's not a normal apostrophe. It needs to be the correct one. And cat data1.txt. What does cat data1.txt do? It just displays the contents of that file. Putting it inside these two backtick operators means that the output of this command, those 3 lines of file, will be taken as the information for this for loop. And it's read line by line. So the effect will be, and we'll see it, is that line will take the first line of this file, then in the next iteration the second line of the file, and then the third line of the file. There should be 3 iterations there, one for each line of data1.txt. If line is confusing, rename it, I don't know, L. It doesn't have to be line. Let's do something with each line. Echo the line and pipe it into cut. Cut takes some string, cuts it based upon some field delimiter. Our field delimiter minus D is the comma, and the field that I want is field number 2. Remember, our lines were delimited by commas. Save and run. Just make sure it does what you expect it to do. Use the website to get the exact syntax. If I've gone too fast there, you can get it from the website. Did it work? Okay, easy. Okay, good. So we take, L will take in the first iteration the first line, and then the second iteration the second line, and the third iteration the third line. We'll echo a line, and then we'll pipe that into cut, which if we delimit by commas will take field 2. Yep. So the cat data1.txt means execute cat data1.txt, and the output of that, by using these 2 backtick operators, these 2, means the output of that will be the input, or as if we typed the output of that here in the file. We'll see another example of those backtick operators, I think, shortly. They're quite important. Let me run mine. You should see something like that, depending on how you change the values. 3 for loops. The last one prints the second field of those 3 lines of that file. Of course, inside your for loop, you put whatever you like. We're just using simple things for this, just to learn the syntax of the for loops. Let's keep going. Example 4. Copy example 3 to example 4. Edit example 4. And we'll show some cases of if statements. The first one, we'll do it inside a for loop. Instead of printing 1, 2, and 3 inside the first loop, let's include an if statement. Let's introduce a variable. I'll call it cutoff with 2 F's, cutoff, and set it to 2. I should be 1, 2, and 3. Our cutoff is going to be 2. Let's introduce the syntax for if statements. If, and they're quite complex. Well, not obvious sometimes compared to other programming languages. If I, $I is the value, is less than minus LT, less than the cutoff. And that condition is enclosed in square brackets, and they're important. They tell the if statement to test this statement, to test if I is less than cutoff. And I think you need the spacing correct here. I think if you don't have a space after the left square bracket before the $, it may not work. Then, if that is true, then echo some message. $I is less than cutoff. Else if, ELIF. So else if, do another test. $I equals cutoff, then echoes some other message. $I is same as cutoff. I'm typing it myself. Sometimes I make some typos and make mistakes. We'll find them later. If you don't want to type it yourself, you've got 2 options. Copy it from the website. You'll get everything. Or just copy from the terminal as I type. All right? If you don't want to type it, then copy it from what you see in your other terminal. But try and understand the syntax. And else echoes something else. $I is not less than cutoff. You don't need the semicolon at the end of these echoes. Won't make any difference. Close the if with FI. What's the opposite of if? FI. And we have our first example of if statement. So this is one syntax where we're comparing numbers. So $I is an integer, is a number, and cutoff is a number. So we can compare them with less than, equal to, and you guessed it, there's GT for greater than, there's LE for less than and equal to, or equal to, and a few others. Shall we run it? Run it just to make sure you've made no mistakes. You can save, Control X, yes, example 4. Okay, so I iterates from 1, 2 and 3. Inside each iteration, the if statement tests the value of I against our cutoff. It's just introducing the syntax. Yeah, best to do it here. There are other ways to do it, but this is just a quick way to get started. Any questions? We work? Press FG. Control X. Now run it. Yeah, the first 3 lines. Oh, dollar cutoff, not percent cutoff. If you make typos, then sometimes you'll get syntax errors or strange results. So you just need to be careful, as with any programming, to get the syntax correct. Okay, let's quickly get a couple more if statements. Let's continue to edit that file, example 4. That was one form of syntax where we compared numbers. We can do string comparison. In our second for loop, where we listed the 3 names, if, and I'll enclose it in double quotes, if name, and a good practice is to include the curly braces. If name, here we use equals to do string comparison. Then echo fi closes the if statement. Okay, so there are no, curly braces like in C to open and close. We use fi to close. Then echo something. And while we're here, let's add another one. So this one is just comparing strings. So we can use equals. Minus EQ to compare numbers, equals to compare strings. And it's good practice to have everything in double quotes to make sure it is a string. Because if $name was an integer, then we'd be comparing a number against a string, which may be a problem. So it should say, it should iterate through the 3 names, and when it gets to Tanaraki, it will echo out a string. Last one. Here we did, what did we do? Here we did a cat on data1.txt. But what if the file did not exist? If there was no such file, data1.txt, then this script would return an error if we try to cat a file that's not there. So it's good practice to check and see if it exists before we use it. And we can do an if statement. If, and minus E means if the file exists, then this is not very useful, because what if it doesn't exist? But I'll just introduce the syntax, then we'll fix it. Minus E is a special operator, is used for testing about files and directories. Minus E means if the file exists. So if data1.txt is a file and it is present in the directory, then this will return true and will echo it exists. If there's no such file, then this conditional statement will return false. Maybe we'd like to do not. If it doesn't exist, then if the file is not there, but we want it to in the next for loop, then we should exit. Not, the exclamation mark is a negation here, so if data1.txt does not exist, if I've got the syntax correct, then echo this error message and exit this script. Don't continue. That's what this exit means. It means we will not go into the for loop. We shouldn't, because the for loop relies on this file. If it doesn't exist, then we should stop. I may have made a mistake with the syntax. We'll come back to it. Let's test and see if it works. Run example 4. Tanarak is my boss, and it shows those values. And let's move data 1 to be data 2. Therefore, data 1 would not exist. Then it handles that case. I'll show you the if statement in a moment, but just check if it does what you expect. When you see syntax error, something's gone wrong. Don't continue. Open up the website, and to get things clear, copy and paste from there to overwrite, so you're back to a working example. So the idea is we check if a file exists before we use it. Everything works, but you're getting errors. To me, that means not everything works. Errors, warnings and errors are not good. Okay. What's it say?
Is there a way to check the line? Here, how do I get the line?
Control C. Maybe a space here. Try to use, I'm not sure, but I think a space there. Yeah. That fix minus E, space before the minus E. Yep. Yeah. Oh no, yeah, okay. If, right, line 9. So, nano. And Control C will tell you the line. Line 3, so you scroll down, a very primitive. Scroll down. What's wrong? If less than. Try a space after ELIF. I'm not sure, I think it's acceptable. If something's wrong, try it. Different. Again. No, there's a problem at the start, but I can't see it. For, do, if, then echo. After the echo, a space. Echo, yeah. Save, yeah. Yeah. Still an error down on line 16, okay. I think you've got two dones. Only the for loop needs a done. So the second done is not. How do you change? Similar, if you go to the website, there's an example about the prompts, and But don't try it now, it's quite confusing. But you'll find it later. Line 15, again, the dones. Only one done. You need one done for one do. Okay, yep. Delete one. Delete done. Yep. And here as well. Yep. Yeah. Okay. Okay. To find the line number inside Nano, you can use Control-C and it will show you the line number. So if you've got an error, scroll down, press Control-C, scroll down, scroll, okay, Control-C, line 36, so the minus E in that conditional statement was a special operator to say if a file exists. There are many others. If it's a directory, if it's a file of a particular type. To find out all of those operators, where am I? These square brackets are implementing a test, okay? And to find out about the syntax, the program is actually called test. So man test will explain the syntax. The square brackets is just a short form of using the program test. And if you scroll through, you'll see all the different operators that you have available. And, or, string comparison, integer comparison, file checks. Is the file a particular type? Does it exist? Is it a directory? And different things. So you can do checks on files. Very useful if you want to automate tasks on files. You want to check if it exists before you do something with it. Q to quit. Do we have one more example of shell script? One quick example to finish shell scripts because we want to move on. I'm going to copy. I know if you didn't get it working, we'll come around and even if you still have trouble with examples 1 to 4, maybe put your hand up and one of the others will come around and help while I try and present, just so we can keep moving. Or I'll come around after I go through example 5. Let's do example 5, last thing. I'm going to copy example 1, our very first one, to example 5. Doesn't matter which one, but example 1 was the shortest. And edit example 5, our last shell script example. We can use input parameters. What's the case? So anything that starts with a $sign refers to the value of a variable, but there are some special cases. $1 refers to the first input parameter to this command. $2, the second input parameter. These are called positional parameters. So ls minus L, $1. So when I run this script, I must enter in a parameter on the command line. Pipe it into grep $2. ls minus L, $1, pipe grep $2. Save. And run it. and we need to pass in two parameters. $1 will be replaced by the first parameter and $2 by the second parameter. And just for this example, example 5 had inside the script $1 and $2, they'll be replaced with the first and second parameter on the command line. And just for this example, it was ls minus l sum directory, user/bin, pipe it into grep and search for a string. The string I'm searching for is VLC, which means find me all files in that directory which have the name or have the string VLC in their name. And it shows you CVLC, NVLC, and a few others. So this is just an example of positional parameters or input parameters to a script, which means you can create a script that takes parameters as input and then reuse that script, and it can be more generic than if it's specific to the files and directories and strings. That's our last shell script. Last example before we move on to some other things. Questions? The things our shell scripts did were not very interesting. It's up to you to put the commands inside to make it do what you want it to do. We just introduced the syntax. Everything okay now? Yeah? Easy? You need two parameters. Where are we going? 50 minutes. Okay.